Alright, welcome to video number 3. This is 17 through the end, 17 through 24 of the review worksheet. Again, video number 1 was 1 through 8. Video number 2 was 9 through 16. This is video number 3, 17 through 24. Alright, number 17. Figure gives the graphs of the function f and g. Function f is given by inverse tangent. Okay, so this is inverse tangent. Which of the following defines g? Oh, so I just want to get to, like, how do I change things to get from here to here? From this graph to this graph, what has happened? Well, I would start at the middle spot there, and it looks like it's gone up by 1. So I'm inclined to think plus 1. But there's multiple ones with plus 1. So let's see. This went from negative pi over 2 to pi over 2. The asymptote shifted up. Okay, so now I'm just thinking about, I think that's right. I think that's it. So the only change from one graph to the next is, let's see, does that spot correspond to that spot is my question. I think so. Or there's the next one up. There's the next. Uh-oh. No, I've got a period shift on this thing. Yeah, because I don't reach 1 until, that's probably pi over 2, and I reach 1 over here, it's probably pi.
Please be careful. Okay?
So I've been stretched out, so my period has changed. So I'm going to go with answer choice C. That's a tricky one. Number 18. Functions of f and g are given by cosine and sine in the xy plane for how much of the interval 0 to 8 pi are they both concave up? Okay. Okay, so I could graph these to 8 pi, or could I graph them 0 to 2 pi and multiply by 4? Probably. So there's my sine graph from 0 to 2 pi. My cosine graph looks like that. So they're both concave up. Let's see, right there. Let's see. Let's just do different colors here. So there's my sine graph. He's cosine up right there. My cosine graph in blue here, he's cosine up right there. So they're both cosine up in between there. Maybe some labels would be helpful. That's pi. That's 3 pi over 2. So for only pi over 2 are they both concave up? Like simultaneously concave up.
That's me.
So for pi over 2 units, but that's on 0 to 2 pi. Right? If I want to go 0 to 8 pi, then, yeah, rather than sketching this whole thing out, I'm going to multiply by 4.
4, yeah.
Yeah, I'll multiply by 4 to get from 0 to 8 pi.
Yeah.
So if I multiply that by 4, that would get me 2 pi.
Yeah.
So if it happens pi over 2 interval from 0 to 2 pi, then that interval is going to be repeated 4 more times. So yeah, I'm good with that being 2 pi.
Yeah.
Yeah, I got somebody who agrees with that answer. He's 3, but he knows PreCal.
I agree.
You agree? Okay. Number 19. The function is given by f of x equals sine of x plus c, where c is a constant. Which of the following statements is true? Okay, so that means we would be shifted to the right by, oh, he finally figured out where to put his hand. That'd be shifted to the, not to the right, to the left by C. Okay. If C is 0, then F is an even function. Uh-oh. Even. So I'm worried about what makes this an even function.
Yeah.
An even function has symmetry with the y-axis. Yeah. So I would like something to have symmetry with the y-axis. My parent function does not have symmetry with the y-axis. So there's my parent function. So it's like, well, how could I shift that so that it does have symmetry with the y-axis? There's pi. There's 2 pi. So if C is 0, it's an no, definitely not. The parent function is not even.
Hey, that's like a trampoline.
Looks like a trampoline?
Yeah.
Yeah, a little bit. This looks like a trampoline bouncing up and down. If C is pi over 2, then that means we would go left pi over 2. So this point would move to here, and this point would move to here, so it would look like this. And now we're symmetric with the y-axis, so I feel good about that. That's answer choice B. There's A. If you want to check the rest of them, if it's pi, then that means we've gone left pi. So we come over here, and now our graph looks like that. That is not even. That's odd, actually. And the original was odd. There's no value. No, we found a value B that would make it even. In fact, there's a bunch of values. Anything that where a peak or a valley was on the y-axis would make it symmetric with the y-axis, which would make it be an even function.
Yeah.
Yeah, he agrees. Number 20.
All done?
Not all done.
Okay.
The vertical motion, the vertical motion, so up and down motion of the tip of the needle on the sewing machine
It's right there.
is periodic with respect to time and can be modeled by a sine function. Remember, sine just means sine or cosine, so we can pick either one. Looking ahead, it's obviously a cosine function. Figure shows the location of the tip of the needle in relation to a cloth plate. Okay. Okay, so this is what we're measuring. The tip of the needle moves straight up and down, above and below the cloth plate. So above and below means, I'm thinking amplitude is 2.5. Obviously that's what's going on here. The table gives a consecutive maximum and minimum displacement of the tip at the 2 times.
Yeah.
Okay, so I'm not really worried about the displacement. It's more worried about time.
Hush, Tatum.
All right, so yeah, I've got amplitude. That's fine. It's really more about the period. So from 0 to 1/24th, we go from a maximum to a minimum. If it helps to see it drawn out like this, from a maximum to a minimum in 1/24th of a second. Okay, this is where it might get misleading. That's not the period. Right?
Yeah.
That's half of the period.
Yeah.
Yeah. So that means my period is twice 1/24th.
I'm gonna be tired.
So that would be
I'm
1/12.
gonna be tired.
So I need to figure out what B needs to be to land with a period
Mommy.
of 1/12.
Oh, baby.
I'm gonna be tired.
Okay, you gotta be quiet.
You gotta be quiet? Yeah, let's do that then. So that means 2 pi over B has to equal 1/12. Yeah, for sine and cosine, period is 2 pi over B, but I know my period is 1/12 because that's when I would get back to a maximum over here. If I want to sort of finish out my table, if you want to get a full cycle in there.
Yeah.
So let's cross multiply, and B equals 24 pi, and that is answer choice C.
Yeah.
So man, that's a lot of words, but
yeah,
when you
that's
figure
one
out what they've given you, it wasn't a whole lot to do. Number 21. Kai, can you move your hands so I can see? Thanks, bud. The table gives temperatures in degrees Fahrenheit in a certain town on a given day. Yeah, high of 38. That'd be nice today. Except that would mean we'd have school tomorrow, so never mind. We don't want that.
Tomorrow.
The sinusoidal function is given by this, or at least models this.
Tomorrow.
Kai, you done with school tomorrow, baby. You're gonna
F is a function. Let's see,
I
time
do
t
think
in hours
the
past midnight.
tomorrow.
Which of the following is true about the value of C? Okay, so this is a lot of words, but C is this phase shift. So let's figure out.
Come here, baby, and I'll explain why.
I've got a max at
Okay.
a max of 38 at 14. So if I'm trying to sketch this out, I really want to go out to 14, I guess. That's my max.
That's your max, yeah.
Well, here we go. So that means I want to shift. If that's my max, that's usually where cosine starts. So I would like to shift 14. So minus 14 or plus 14.
Because it's so cold outside.
Well, minus 14 would move me right 14.
So all of us are home together.
Plus,
Okay? Yeah.
minus 14, minus 14. Is there something different about these two answers? I like minus 14
For Daddy tomorrow either.
because this counts for a phase shift. Oh, not a vertical shift. Vertical shift is up and down.
Not you.
This is not what we're talking about here.
Okay,
C,
for JT.
that C is a left and right shift. Oops. So I can throw out the vertical shift. C is not a vertical shift. C is a left and right shift. And I want to go right 14. So minus 14. Again, going right 14 would put me at my maximum. So I want the max to occur at 14 hours. So I need to move it right 14. So C is minus 14. 22. Part of a video game involves the use of one period of a sine function as the path that a spaceship follows across a rectangular video screen. The video screen has a width of 1,000 pixels. So width of 1,000.
Oval.
A height of 600.
Make a circle.
The values x equals 0 and x equals 1,000 represents the left and right sides of the screen, respectively.
I do this like that.
0 to 600 represents the bottom and top. So this is sort of our.
Hey, Kai, Daddy's talking, okay?
That's our XY plane there,
Stop talking me.
where it goes out to 1,000 Change that up a little bit.
Stop talking me, mommy.
and up to 600. Okay, so 0 to 600 on the Y, 0 to 1,000 on the X. The path of the spaceship begins on the left side of the screen at x equals 0, completes one period by ending on the right side of the screen at x equals 1,000. So I think it just told me that my period is 1,000. It's a long and complicated way to say that. During its path, the spaceship reaches a minimum height of 200, a maximum height of 500. So from 200 to 500, because now I'm thinking about amplitude and midline. Which of the following could define f of x? Okay. Let's see. Okay, the period's all right because they're all the same. The midline is 350, so that's fine. My amplitude is definitely 150. So my next concern is, let's see. My next concern is it a negative sign or a positive sign? Well, let's see. During the path, the spaceship reaches its minimum height of 200 before reaching its maximum height of 500. So I think that before is doing a lot of work here. That means I've got to go down before I go up, because I got to hit the minimum first. Okay, that's why, man, that's tricky. That before is doing all the work here, meaning it's got to go down first to hit the minimum. So if it goes down first, it has a negative out front. I almost said negative amplitude, but there is no such thing as negative amplitude. So it's got that negative out front to create the reflection to make it go down first, so that it hits its minimum before hitting its maximum. 23. Theme park thrill ride involves a tower and a carriage that moves up and down on a vertical axis as shown in the picture, almost certainly according to a sinusoidal function. The ride involves 10 bounces from the highest point to the lowest point and right back to the highest point. So like 10 complete cycles. Point X is located on the bottom of the carriage. It can be modeled by a periodic function. Oh, and I got sines and cosines here. I get to pick which one. At time equals 0, okay, this is where I start to sketch this thing. X is at its highest point. That sounds like I'm starting at a maximum. That makes me think cosine of 120. The lowest point for X is 20 feet. The lowest point for X is 20 feet. The next time X is at its highest point is time equals 8. Okay, so that's my period there from 0 to 8, which is the end of the first bounce. Yeah, that makes sense because it came down and then went back up. Which of the following can be an expression for that height in terms of seconds? Okay, well, I'm starting at a max, so I'm definitely looking at cosines here. Throw out the sines. My midline is 70. They all have that. My amplitude is 50. They've all got that. So I'm trying to see the difference between B and D. And that would be a period thing. Okay, period is 8. So that means 2 pi over B needs to be 8. Yeah, 2 pi over B is 8. So cross multiply if you like. 8b equals 2 pi. So divide both sides by 8. So b is pi over 4. And now I'm looking at answer choice B, not answer choice D. Because they gave me one complete cycle, told me it was 8 seconds. So I was able to figure out that B was pi over 4. 24, last one. Calculator, which don't have a calculator for the test, so we'll see if I can do this without. If not, I'll grab a calculator. The table gives the temperature in degrees Fahrenheit a certain town on a given day, selected hours past midnight. A sine model is given, calculated using all 5 data points, where t is the input value. Okay, crisis averted in the Wolf household. So regression value, t is input. Based on the regression model, which of the following is the best choice for the amplitude of the sinusoidal function? Okay, amplitude would be the distance from, as you know, the midline to the maximum. I don't know if I can do this without a calculator, especially if it's one of these. It looks like my midline. No, my minimum's at 83. This looks backwards, right? Because it starts out going down, up, and then down again. So my minimum's 83. My middle is 91 or 92, something like that. And my max is 102. So my amplitude on one side looks like it's 102, excuse me. Looks like it's about 10. On the other side, it's about 9. Without plugging this in, I'm not sure, so I'm supposed to have a calculator. You won't have a calculator on the test, so you're not going to get answers that are that close to each other. If I'm guessing, it's 9.5, just because it looks like 9 on one side and 10 on the other, so you average that out to 9.5. But without a calculator, I don't know. I'm hesitant to commit between A and B. It's obviously not C or D. C looks like The total height of the wave, that's not it. 92.5 is probably the, that looks like the midline of the wave, so that would be D. All right, sometimes we ask for that. That's not anything. So again, it's either A or B. I'm going to guess A. I'm not committing to that without a calculator. Again, you won't have a calculator on the test. You do have questions like this, but the answers will be far enough apart where that won't be a problem. You'll be able to figure it out.